Ladies and gentlemen of BlueHat 2025, trust nothing.
Hi, everyone.
Hi, everyone.
It's a pleasure to be here. Thank you very much for the weird AI introduction. We're super happy to be here. I'm Gal. I'm the co-founder and CTO of ArgoCD. With me, Avi, the really smart guy. I'm just here to look good. And we're about to dive to a really interesting story, the story of the 0000 day. And let's start. So a quick agenda. What is the concept of client port scanning? Or if some of you know or don't know, you've probably been port scanned without you even knowing. The whole concept of private network access, which means what the work that has been done in history by the browsers to try to segregate between private internal networks to the World Wide Web. The 000 day itself, the bug, the flaw that made everything happen, the internals and how everything is actually possible. And then we're going to show some cool example of our seeing some cool applications, and in the end, talk about what the browsers try to do, or a little bit of a spoiler alert, didn't succeed on doing in the end, and the whole story of it. So without further ado, I'll let Avi start, and again, thank you very much, everyone.
Thank you, Gal. Thanks, Gal. Thanks for being so awesome. So I ran into the following headline one day. Does anyone remember it, and anyone ran into it? It's off. So it's about a website that, as soon as you visit, starts port scanning you. So I know it sounds weird, and some of you might have port scanned some IPs on the internet, but client port scanning means that websites were basically able to scan the visitors of the website for any reasons, whether it's for security, or for tracking the users, fingerprinting them. The idea is that it should not be possible in first place. And this is how it looks. Basically, eBay were using the loopback 127.0.0.1 IP address. And they, as you can see, they spawned a lot of requests for many different ports on the computer that is currently visiting. Through the browser. So browsers can actually route and make requests, in case you don't know, using JavaScript. And today, this is not possible. Like, this IP cannot be fetched under ebay.com. You understand why. And it's thanks to PNA, Private Network Access. And I'll try to dive into what it tries to solve first. So Private Network Access basically tries to distinguish the World Wide Web from your office or home network, and the home and office network from your local network. Basically, it says the following notion, that a public website should not be able to query your router just because you have some IP reachability. It does not mean that the browser should allow this request to propagate to the router, and the same can be said on Localhost. But the contrary is possible. So if you're currently on Localhost, you can access example.com, but not the other way around. And it's currently pioneered by Chromium, the Chromium team. They started with it, and basically, we love it. It's a very welcoming initiative, and it is required. Let's understand why they did it. So we have many ways to run a server, more than one. Here are at least 4 ways to run a server. Is it safe, like from a first glance? So the answer is no, and not even the last 2 examples. They're not safe. Basically, browsers can access Localhost, and all the browsers try to tackle it for a lot of time, for almost 20 years, and they failed to do it to this day. So let's dive into an 18-year-old bug that I found, and I wanted to share with you. It's more of a story. It's not like just one bullet or something like that. It's basically a 20-year-old bug. It's not 18. It's like almost 20. And it's unresolved to this day. Now, it affects every browser, not just Chromium, Firefox, but It begins with the lack of standardization in Mozilla's forum. So some random dude posted this vulnerability or bug to mitigate CSRF attacks against internal networks. Basically, they said the following. Listen, guys, any website can currently scan my home network. It's broken. It should not be possible. Then, shortly after, someone said, guys, it's actively being exploited. Like, people are aware of that. It's not even a secret anymore. And I'm talking about 19 years ago. So basically, what attackers were doing is simply planting each one of those script files. I hope you use JavaScript, or sorry if you use JavaScript at the same time. I love JavaScript, but it enables, in case you don't know, just placing this script tag inside your website will basically dispatch a request that changes the settings of your home router. It modifies the DNS server that is being used. And this way, attackers can actually make you serve to their website. They can take over the transport and route you to specific malicious domains just by accessing google.com. It's called drive-by farming. It was a very big discovery by Symantec, and it was a while ago, yeah, so it's not new. 300,000 assets, at least, at the time of the research, were exploited as a result of this bug. And basically, PNA tries to solve that. It tries to make the requests fail in first place, instead of leaving your device. Now, they try to come up with a list of IP addresses or segments, cedar blocks to block. Now, you can see something is missing, already. But then someone said, guys, it's not a Firefox-specific issue. It's basically everyone's fault. So here they started a hot potato game, basically throwing the responsibility from browser to browser and saying that it's not specific to Firefox. They might be right, but it's still an issue that should be solved. Now, as you can see, he said it's a request for enhancement. It's not even a bug. OK, so I just want you to understand. People are getting attacked, 300,000 compromised routers, and it's an enhancement in Mozilla's eyes. Now, someone smart found that this IP address was forgotten, and it might be added. It's not even this important. It's not that important, but it should be added, just throwing it out. So they added it to the list, but then nothing happened. That's the sad part. So this list is specific to Firefox. Chromium, at the same time, started working on private network access and maintained their own list. They also forgot 0000. And then they basically said that Mozilla, Firefox, they said that we wait for Chromium to finish implementing private network access, and then we'll follow the standard, once it's standardized as an RFC. So they created an RFC. It's still under ideation, but it changes every day. And as we speak, it's a new RFC that basically tries to define how websites should access more private domains. Private network access, everything I said back in the slide where you had the public network, the home or office network, and the local network. And it basically depends on it. So they wait for Chromium. They said, it's not our problem. Chromium is trying to solve it, systematically. And we'll wait for them. So let's understand what is allowed as part of private network access. And basically, it tries to solve the lack of standardization. This is the first thing. Because there isn't a standard, they try to define what browsers should do and should not do. Just like you have CORS, cross-origin resource sharing, but CORS is dealing with the response. So the request is still dispatched, and it reaches the server. And in this research, we proved that this fact enables arbitrary code execution on internal networks, and it is enough to just dispatch a request. So private network access just tries to solve it and block the request from being propagated and sent in first place. So they tried to roll it out in Chromium 94 or 96. They tried to roll out this feature. And apparently, they tried to mitigate CSRF attacks as the title of the original thread in Mozilla. But they also forgot 0000, as I said. They have not decided what they should do, so they left it aside. Then something interesting happened. They tried to roll it out, and they broke so many websites all over the internet that they have to revert these commits. Basically saying that we know in defiance of specs, developers want this IP address to be translated to localhost. This is basically what they're saying. It's breaking many websites, therefore we need to do it more responsibly. And that's it. Basically, they tried to solve it. They could not. They had to rethink. Now let's understand what this weird IP address means. First, it has multiple uses. So this is it's very weird.
What does that
right?
mean? Multiple uses.
Yeah. So some of you might know it as all IPs on this host. For some of you, it's like bind on all network interfaces. Some of you might have used it when configuring like firewall rules and using the CIDR blocks as a notion of all IPs. Or sometimes we just mean localhost. So it has many different use cases. But what does the standard say? And what we just went and looked at the RFC, because this is the standard, and this is the source of truth. Now, the RFC says that it is described in the RFC as 00. Basically, it says that it must never be sent as a target IP address, which was definitely new to me because I've used it more than once. Now, it might use this IP as source address only when DHCP was not done yet. So before you have an IP, you boot your computer, you don't have an IP address set. So when you lease an IP with the DHCP server, you have to present some IP as a source address, and this is the only real case where 0000 should be used as part of like the DHCP handshake. Now, Chromium added counters to estimate how many websites and which websites are trying to access this IP. It was around 0.002 at the beginning, but then something very interesting happened. And we saw a spike. Now, can you imagine what happened like in this graph? So it was actually our disclosure and our DEF CON talk, exactly in these dates.
So what do you say, Avi? You mean attackers are looking at DEF CON talks?
Yeah. In case you didn't know, like you guys are watching these talks and watching the Google threads, and like I went and read this thread on Mozilla. This is exactly the stuff that attackers are doing, and sometimes it's just out there in plain English, and it's awaited to be exploited. Now, it's very cool because you can see there's a spike, but there isn't, it stopped. It went back to the normal. And this is because browsers have been blocking it after our disclosure. But what took them so many years? Like, it was open for 18 years, and only like recently it was blocked. So basically, everything on the left figure was possible. You can access localhost, the host file records, your home router or office network. And basically, everything is blocked today as part of private network access. But they left 000 aside because it's a weird IP that has too many use cases, and it's very hard to confine. And apparently, it enables accessing localhost and 127.0.0.1 IPs. So it's very weird, but it's kind of not a bug, it's kind of a feature. And as attackers, we asked ourselves a question, what can be accessible using this attack vector? So basically, everything that works with HTTP, so not HTTPS because there is an HTTP, you can use like port forwarding if you ever use the Kubernetes to access a remote pod, or use the kubectl port forward and such. So these are accessible too. And also, you can access internal networks. So if you're already connected to the VPN, every request will basically be wrapped automatically, and this way, you can actually bypass every security measurement that is network-based or that looks on the, at this level. So we went and wrote a port scanner. You can also test it yourself afterwards. But the thing is, we were able to scan the ports of the visitor with very few steps. It wasn't hard. And our secret was just using 0000. And using localhost did not work. We changed to 000 and found out everything still works. Now, when I visit the website, this is how it looks. You have this is the Wireshark sniff of the handshake. So first you have the HTTP GET. I hope you guys can see it, but you have the handshake and the request for the web page. Then it starts port scanning. You can see the red lines. There's TCP reset packets, basically connection refused. And this way we were able to map in the JavaScript context whether a port is open or not. And if this is not enough, you can also use malicious domains and basically map any domain to this IP address. So yeah, it's that simple. You can actually confuse some browsers to this day using this technique. And the only way to protect yourself against this at the moment is by adding specific checks to the server that is running on localhost. So nothing at the browser currently stops you from doing it. The maintainers and all the projects in the world have to handle it just like they did with the course. Now, this gets me to ShadowRay. ShadowRay was a really big attack campaign. Basically, the first attack on AI workloads that we caught in the wild. And it was very interesting because we searched for RC, remote code execution. And as a user of Ray, I love the framework. I really hope you have used it. In case you didn't, I encourage you to go and try the quick start even today. Basically, Ray is like Kubernetes for Python. It's the way to scale AI workload. And if these logos are not enough, OpenAI boldly claimed that they use Ray to train ChatGPT, which is huge, right? So it's really changed the way many engineers, including myself, work with Python. And it leads me to this advisory, which we also ran into by mistake. Basically, what we saw is that there are 5 CVEs, vulnerabilities, that were reported to Ray. And basically, it enabled remote code execution, which is a very severe, 9.8 CVSS score, critical CVE. And they tried to dispute it, basically saying that, yeah, guys, 3 or 4 of the CVEs are accepted, but one of them is core functionality in Grace. So it's not really a vulnerability, but more of a bug. Now, as you can see, they also have it in their documentation, and they released the advisory saying it's the only purpose of Ray is to run arbitrary Python code. So basically, in the same way that you don't confine Kubernetes, Kubernetes can run basically any kind of workflow or pod. It does not distinguish the bash commands that are able to be executed. So in the same essence, Ray is like Kubernetes for Python and more of the orchestrator of all the Python processes. So it has to run arbitrary code in order to function. And it assumes it's running in a safe environment. So get this. We have a public report. We have a critical CVE. And the vendor basically says that it's an intended behavior. It's not even a bug. Remember I said attackers are looking exactly for this kind of stuff. So this is exactly what happened. We went and tried to see and figure out whether some vendors were already exposed and compromised. So basically, as I said, these features, this is what attackers look after. And this is exactly what we are also looking after when researching. We search for disputed CVEs, and that's it. It's really interesting. Now, shortly before I pass it back to Gal, I wanted you to understand why so many servers were compromised before diving into the findings. Basically, the the default configuration of Ray will set up a vulnerable cluster. This is the set part. So it exposes the Ray on all network interfaces, and the vulnerability is very simple. As soon as you initialize Ray or import it, there is a job API running at a specific port that is very unique to Ray. And basically, it accepts bash commands as input, executes them, and returns the response, like RCE by design. So the world did not know about it. And there were many, many exploited clusters in the wild. And I'll hand it back to Gal to go over what's have been compromised.
Thank you, Avi, for being so awesome. So, who heard about the ShadowRay story? This is basically the first known attack campaign targeting AI workload in history. This is today de facto the only and sole example. You can find it in the MITRE technique for AI attacks, which called the Atlas. And even our friends at Google, which invented Kubernetes, did a whole lecture about how Kubernetes might be used in an unsafe way and what it might lead. So a short recap, we found attackers at the biggest corporate networks in the world, the top companies of the world being compromised. It was not only for financial usage. We saw private SSH keys being leaked, password, lateral movement on the cloud, production DB being stolen, and a lot more. We saw OpenAI keys, Hugging Face keys, Slack, even Stripe. We could take the money, right?
Yeah.
And what was really surprising, not only for us, is the fact that attackers, first of all, left a lot of traces. When you register a new job in Ray, basically it's like running a new pod. The command that's been executed is being registered in the history of commands, and in that way we could actually follow the steps of the attackers. And we found out that the attackers know a lot more than us in each and every machine, and we're talking about a very pricey GPUs of NVIDIA. There were more than 5 crypto miners, and they were aware of each other. So we literally saw the binaries having in their own code the script to elevate the privileges, look for other crypto miners, kill them to own the resources, and our Mr. Attacker was forced worldwide in the crypto mining pool. So the attack went successful, right? Maybe we're in the wrong field. And this campaign was hitting waves, was published over Forbes. And when we got a chance to talk to a lot of our customers and friends and colleagues, we saw there's a false sense of safety when everyone said, oh, okay, if it's internet-facing, so only then attackers can hack it, right? Like if it's behind a firewall or WAF, or it could not be hacked. So this really made us rethink how we can chain everything together, taking a real example of a real global campaign, and how we can chain it together with the 000 day in order to see how we can basically break all of the concept. And by leveraging the browser itself, you are already authenticated, and you can hack internal applications like Ray. Just to remind you, all we needed in order to execute code is just one packet. We don't even care about the response, and we can completely take over. So passing it back to Avi. Avi, thank you for being awesome, and
thank you, Gal.
Show them the money.
Yeah, so this is where the more fun part of the presentation begins. Now let's understand, we have a local running Ray cluster, and we want to attack it. We want to run arbitrary code. Let's say I'm a developer. I have Ray running on Localhost, and my goal was to trigger code execution from Gmail by clicking on a link. And we managed to do it. Now, basically, here's the flow. First, you need something vulnerable on Localhost because it's not a vulnerability in the browser itself. Like, if a browser had something that's constantly listening, we might have abused it, but it does not have. So we need some external service or a third-party software that runs on your local machine. And just a hint, if you'll do netstats, so you'll find many open ports. Some of them are your operating system services that does not have authorization by default. Basically, everything that runs on Localhost is assumed to be running only locally. So you never add authorization. You don't have HTTPS. Like I know I sinned with it like a lot when developing. And you don't care about security when it's Localhost because seemingly everything is local, right? So here's the thing. I sent this Gmail phishing email, not the best one. I didn't use ChatGPT, but just like for the sake of example, it navigates me to ports.sh, some website domain that I own. And as soon as I visit this website, I invoke JavaScript. The web page has a JavaScript script inside of it that is triggering 0000 as target IP. And it basically posts an HTTP request to the jobs API. Now, here's how it looks. First, there is a netcat reverse shell command, which opens bash and connects the STD out and the STD and everything to a remote control server. Then I'm using mode no course, which basically says to the browser and the JavaScript fetch API, listen, I don't care about the response. Like, all I care is dispatching the request. Many frameworks and websites use it for analytics when you only want like to upload stuff and don't care about like whether it's received or not, like more optimistic scenarios. And I use 0000 IP, as I said, and it's so simple. I said it's an integral part like of Ray. So all you need is like an entry point. Entry point is the command line, and Ray will just run anything you say. Apparently, like, it looks like an error if I would have looked at the developer tools, but you can see that I have the 200 OK status code, which got us thinking, and we went and actually looked at the dashboard and saw that the code actually reached the server, and we have executed arbitrary code. So just to make sure you got it, we clicked on a Gmail link, and it exploited an application that is running locally on my machine and listens only on localhost. This is huge. This is how it looks if you refresh the page several times. So every HTTP request triggers a new code execution. So it's not even like based on some luck or statistics. It's like 100% working exploit that's cross-platform and cross-browser. This is the really interesting part. Now, I swear Microsoft did not pay me to say it, but like Windows, actually, for the first time, is not impacted by this vulnerability. I know it might be funny. Yeah.
Even though we do accept cloud credits.
Yeah. Yeah. But the thing is, Windows, they read and implemented the RFC correctly, and they actually block this weird IP at the kernel and the OS level. So the browser cannot even like do anything. If something listening on localhost, it's really local, unlike in other platforms. Now here's the demo. Bear with me. Now on the right, I have a local machine. On the left, I have a VPS somewhere on the internet. And in the middle, I have a Gmail incoming email with a malicious link inside of it. Now, on the right terminal, I open a Python shell, and basically the interpreter imports Ray and runs ray.init. Ray.init opens the dashboard on localhost. And it's bound only on the local interface. It's important to mention. Now, here's my phishing email, and I'm opening a netcat and a socket for receiving connections on the left terminal. Now, as soon as I'll click on the link, it will trigger JavaScript execution. You can see I have a new connection on the left, and you can see that I have a new job executed in Ray on the right. So it uses WebSocket. You can even like see the job popping up in real time. And I have a reverse shell somewhere on the internet to my computer.
No.
Yeah.
We are a little bit afraid of the demo gods and from Ida. They told us not to connect to the network, but the website is fully working. So if you want to hack yourself or your networks, you're welcome. You can just serve to port.sh, and Avi will say hi from within your servers.
Yeah, as I said, this vulnerability is still working on some of the browsers, more on that soon. But the thing is, it made a lot of buzz, and this actually made the browsers sit together and solve it instead of playing a hot potato game and passing the vulnerability between one browser to the other. You remember that Mozilla said they work for Chrome, so now the contrary is true. Now Chrome waits for Mozilla to implement it in Fetch, but we'll get to that in a second. So it made tons of buzz, and we reached all the vendors, and they wrote about it. The thing is, Ray is just one use case, and I didn't have more time for demos, but There is also Selenium Grid. There are other services that are running on localhost if you use Macs or Linux. So there are a lot of attack vectors, and basically we say that localhost is only seemingly local, so I want you to keep that in mind. And this is why it made so much buzz, because it's been out for 18 years and nobody took responsibility. Nobody fixed it. It's such a weird IP address that they did not know what to do, and finally it's fixed, at least partially. Now let's talk about the browser reports and the breaking changes. I'll begin with Apple WebKit. I said it's cross browsers, but Safari were the first ones to fix. They did not ask any question. They just fixed it right away. They understood that it's against the RFC. You guys are right. And I'm sorry, but I added an if clause to every HTTP request on Apple devices. Basically, it compares the destination IP address, and if it's only zeros, it does not allow the request to be passed. So this is very cool. We added an if statement to any Apple device in the world. Now, Chromium. Chromium started with PNA. They were the pioneers, and they really put a lot of effort into security. They tried to roll it out gradually at first place. So like you have headers for cores, if you ever developed a server and ran into some course errors, you must have tried to add X origin, allow something, or whatever headers. You need to support or add the support for cores to your own server, right? So the same will be applied with private network access. There are new HTTP headers that will be added to servers. It's still not finalized completely, but this is definitely the direction where Chrome is going towards, and they've started to roll it out and ask people to add these headers in case they allow the website to be loaded under external domains. So this way you can kind of make an exception to PNA, and it's really nice. They said that people are getting attacked. Thanks to our report, it's also mentioned in this block. And they mentioned everything we just showed you, the DNS rebinding attacks, and that it was overlooked and brought up again in one of our disclosures. Back then, it was 0.001%, now with 0.15%, so it's 15 times more. As soon as the vulnerability and the disclosure went out after our DEF CON talk, we saw the spike, and at least in Chromium, they tried to block it, but they passed the responsibility back to Mozilla now, which leads me to Firefox. So Firefox and Mozilla, they are in charge of the fetch, the JavaScript API. There's a standard. If you ever use XML HTTP request or fetch in JavaScript, so Mozilla are in charge of the RFC, and they lead it. They don't treat 000 in any special way at the moment. They wait for Google to figure it out while Google is waiting for them to figure it out. But there is an open PR in Fetch, the specification. And after it will be merged, so all the browsers will comply with the new standard and block 000 in every browser, in every platform. Now, what we can expect. So remember the HTTP headers I showed you? We added coarse HTTP headers. We should add new HTTP headers for private network access. Eventually, we really hope, and it should be happening soon, that 0000 will be blocked in the fetch level. So it will be a cross-browser solution. It's changing an RFC is not that easy. It does not happen overnight, but it will happen. And my recommendation to you guys is to basically think and keep in mind that localhost is only seemingly local. You should not assume something is safe just because it runs on the local network interfaces, because every application that has routing capabilities, and your browser it has routing capabilities, is basically able to communicate with this software. And authorization, authentication, basically the smallest walls you place in front of your app. So authorization, authentication, and HTTPS, all of those should basically eliminate this attack vector because they include the handshake. So you cannot do a handshake with a single HTTP. So these are all very low-hanging fruits you can do to secure your own infrastructure at the moment. And a nice story, you know these port scanners online where you can like specify a domain and make it a port scan some website? Apparently they've blocked 127.0.0.1, but you can make them port scan themselves using this IP. Like it still works, I checked yesterday. Yeah, what a weird IP. Gal, I'll pass it back to you for conclusion. Thank you very much, guys.
As you all see, we really felt that there's a big gap in understanding the fact that people think that and seem that private internal web servers are safe by design, right? We have a firewall, we have a WAF, we have so many network security tools, but in the end, those apps can be attacked like any other apps, and they should have the same mitigation, the same control, authentication, authorization, protecting your apps from within. This is just one way to show how we can bypass the legacy approaches, and private internal networks and private application can be attacked by attackers from the outside. And we think this should be a community effort. As you see, the hot potato game of responsibility in the end falls underneath the users themselves, which are the ones that are raising this awareness. Google proactively claimed that no one should use it, and if a website is using it, it's malicious by design, and we saw hundreds of thousands of malicious websites out there, not only Avi's one. And of course, you can go to the blog and read more and try to reproduce it yourself. And it is part of a big trend right now when developers themselves, they hold a lot of the credentials and secrets because they work directly with the cloud. So with this whole trend of targeting developers, this goes even farther. So again, thank you very much. It's been a pleasure. If you have any question, you can reach out via Twitter or X or whatever you want to call it, and thank you very much.
Thank you.